All right, everybody, today we're going to be going over the test review. I'm going to work through all the problems, and I'm going to go ahead and explain each problem so you'll understand what to do during the test. First one says, how is a constant term different from a variable term for an expression that represents a real-world situation? Place the correct term with the correct definition. The two choices are variable term and constant term. We have to figure out which space they're going to go into. Space number one says changes in value whenever the value of a variable changes. And the second one says does not change. Well, by the very nature of these words, you can kind of tell what goes where. First of all, this says it changes, okay? Another word for changes is it varies. So the word variable basically lets you know that you're going to make some changes, all right, from time to time. And right over here it says the value of the variable changes. So the variable term fits this spot. Next it says does not change. Well, constant is a word that means it does not change. It's constantly the same. So that means the second one would best fit for the definition constant. Let's go to number 2. Write an expression equivalent to 6x plus 4y minus 2y by combining the like terms. Enter the numbers into the boxes. Well, if we combine the like terms, remember, as long as I'm adding, I'm allowed to go ahead and move my numbers around. So let's go ahead and see what I can do here for adding. I decided to switch the presentation so I'll be able to go ahead and write. Well, remember, first we can go ahead and use the additive inverse to make this addition. So this would be 6x plus 4y, and now it's going to become plus negative 2y. Now that I'm adding in my expression, I'm allowed to move things around. I can move these parentheses to where I can put them around the 4y and the 2y. Well, they're like terms. So I can take 4 minus 2, and that will give me 2y. So under the y's, I'm going to put 2. Then we have 6x. There's nothing to combine with 6x, so 6 will go right here. Notice I didn't put 6x. The x is already here, and the y is already here. I just needed to put the numbers that needed to go there. Question 3. Each month, a phone company charges $20 for 500 minutes of talk time plus 45 cents for each additional minute. Unlimited texting costs $30 more. Choose an expression to show the cost of talks and texting plan for 1 month given X minutes over 500. Well, we see that they're only going to charge us $20 for 500 minutes. But they also say they're going to charge us 45 cents for each additional minute. So let's not get hung up on the 500 minutes. What it's costing us is $20 plus 0.45. And since they're charging us for each minute, that would be 0.45 M. That's 45 cents for each minute. The unlimited texting is $30. Well, that's just a one-time fee each month, and they're not going to charge us for any extra texting. So I could just add $30 to that. That's going to give me 20 plus 30, which makes 50. And the 45 cents, represented by 0.45 M, comes down. So my answer has to be 50 plus 0.45 X. Don't get hung up on the variable, whether it's M, X, C, or A. All we know is we need a variable there to represent the unknown. Question number 4 says, which expression is equivalent to this expression? Once again, we got to combine like terms. I see that we're adding here, but we're not adding over here. So this will have to be a plus negative 3a. All right, let's go ahead and find the things that match. I've got an a over here, and since this is negative 3a, I can put the minus 3a underneath it. And since this is negative 6b and this is positive 2b, I can put the plus 2b over here. 4a minus 3a is going to equal 1a. And negative 6 plus 2 will be negative 4. So my answer should be a minus 4b. All right, let's go to number 5. Which expression is equivalent to the expression? Well, once again, since I'm adding, I'm allowed to move my terms around. I'm going to take this negative 3a and put it over here. I'm going to take the positive 2 and put it under here. I can combine my like terms. 10 minus 3 is 7, so it would be 7r. And negative 5 plus 2 will be negative 3, so that would be minus 3b. Next, we got number 6. Which expression is equivalent to this expression? Well, this time we're subtracting. And remember, when we're subtracting, we've got to turn it to positive before we're allowed to combine. So I'm going to multiply this negative to everything inside of the parentheses over here. The negative times 3a becomes negative 3a. And the negative times positive 2b will be negative 2b. Now I can combine my like terms. I've got a 7a over here, so I'll put the minus 3a underneath it. And I've got a negative 3b here, so I'll put my negative 2b underneath it. Now I've got 7 minus 3, and that's 4a. And I got negative 3 and negative 2, and that's going to make negative 5b. Well, I apologize. I never did mark the correct one here. Let's see. This should have been an A, not an R. Sorry. 7a minus 3b, right here. All right, let's go to the next page. Next, we have number 7. It says, how is the commutative property different from the associative property when related to an expression? Place the correct term with the correct definition. Use one, more than, one or none of the definitions. Okay, you can use one of them, more than one of them, or none of them. Associative property, where would that go? Well, the first one says allows you to move terms as long as you're adding. No, if I remember right, associative property allows me to go ahead and move those parentheses around. Number 2 says allows you to move terms as long as you're subtracting and dividing. No, that doesn't work either. Number 3 says allows you to move groupings, parentheses, as long as you're adding and multiplying. Yeah, that does sound like associative property. So I would write that into this block. Next one says commutative property. And that fits my first definition. Allows you to move terms as long as you're adding and multiplying. I'd leave the rest of them blank because there's nothing else to fill in here. Number 8, a set of speakers costs $22 and songs cost $125 each. The sales tax rate is 75%. The expression 0.75 times 22, sorry, looks like 0.075 times 22 plus 1.25s can be used to determine the amount of sales tax due to the entire purchase. Expand the expression and round to the nearest hundredth. Use 2 of the numbers below to complete the expression. Well, expanding means I'm going to take the first number that's by the parentheses and multiply it to everything inside. We call that distributing properties. So I have to find out what is 22 times 0.075. Let's work that one out first. 22. Let's see, and I can go ahead and add a 0 later, and let's just use 75 here. All right, let's give this a shot. The first one's going to be 10, so that'll be 0, carry the 1. Then 14, so that'll make 15. And then I'll carry the 1 again. And 2 times 0 is 0, and carry the 1 is 1. Now I've got to do the same thing to this one. Well, the reason I set it up this way is I'll get the same exact number, because I'm still multiplying by 2. When I put them together, and then we'll put 5 over here, 6 here, 1 here. All right, we remember that we've got 1, 2, 3, so 1, 2, 3 is going to put my decimal here. So I'm looking for 1.65, and look at there. So I would take this one and write it in here. Next, I'm going to take this number and multiply it to 1.25s. Well, if I take 1.25 and multiply it to 0.75, well, 5 times 5 is going to give us 25. Here are the 2. That's 10. That would be 12. Here are the 1. That would be 5 times 1 is 5, and then add 1 is 6. Now remember to put that 0 there. And now I've got 7 times 5. That's 35. Carry the 3. 7 times 2 is 14, plus 3 is 17. Carry the 1, and that's 7 and 8. Well, this would be a 3. Let's see here. I'm sorry, that's a 5, not a 3. Then 2 plus 5 is 7. 6 plus 7 is 13. Carry the 1 is 9. When I move my decimal over 1, 2, 3, 4 spaces, I have to round up because we're talking money. I think we're going to be talking, let's see, I remember this is 1, 3. Did Mr. Mendez add wrong? No, it should be about 14 cents, right? All right, realize that this is not a 1, this is actually a 9. So we're rounding up to about 94 cents. Let's see, and did I get all of those? Let's see, well, I'm sorry, 1, 2, 3. Actually, 1, 2, 3, 4, we're going to be rounding this up to 1, 2, 3, 4, 5 spaces, because we have 1, 2, 3 dots here, right? Decimal places here, and then 2 here. So actually, it's going to be 9 cents, 0.09. See if we got a 0.09 here. There we go. So I would take this one and put it here. All right, let's get number 9 out of the way. Use the greatest common factor to factor this expression. As I look at this, I see that I can factor 3 out of each one of these. 3 times 2x will give me 6x. 3 times 5y will give me 15y. And 3 times negative 9 will give me 27. So my right answer must be right here. And the last one, use the greatest common factor to factor this expression. I would say out of these, I could take out, I want to say 8. Let me see here. 56, yeah, I believe so. If I take out 8, 8 times 5x will be 40x. And 8 times 3y will be 24y. And then 8 times negative 7. So that means my last one's here. All right, went through all these. Hope that helps. Please remember how to factor. Take all the numbers, break them down, and find out what the things that are alike. I know I did that kind of quick, but I have to go to a meeting right now, and I'm short on time. So I'll see you in class.